Today I'm going to talk about seagrass restoration test plots in the Atlantic, subtropics, and tropics. This is an overview of where I worked, and the blue shows Biscayne Bay, Florida. The red is coastal Texas, up and down between Galveston and Laguna Madre, and the purple is the island nation of Jamaica. This is Fred Short's Seagrasses of the World model. Basically, we had in the three places 253 trials, 83 sites, 300 hectares planted, 3.4 million planting units, and we used three basic species: Thalassia testudineum, Halidule wrightii, and Syringodium filiforma. Methods were seeds, plugs, and sprigs. And the tip of South Florida is tropical, as is Jamaica. Texas, most of it is subtropical. And the success of the test plots were around 77%. Biscayne Bay is 56 kilometers long and 7.5 kilometers wide. It's been urbanized highly at the north end, and it's a preserve, both federal and state, at the south end. The urbanized part is about 120 years old, and it has 9 causeways across it, all from the bottom of the bay. And almost everything you see here, all the shoreline, is all dredged and filled, as are all these islands in the middle of it. This, of course, is a natural island of Biscayne, of Miami Beach. And basically, the urbanized part goes between the city of Miami and the city of Miami Beach. We used 6 techniques: Thalassia sprigs, Thalassia seeds, Halidule sprigs, Halidule plugs, and Syringodium sprigs. Basically, we had 13 sites, but some of them we combined. And here in green, you'll see those that we felt were worth trying. And the green ones range between 53 and 97% success for Thalassia sprigs. For Halidule sprigs, they go above 100% because they became very thick and coalesced. They go from 50 to 100%. And Halidule sprigs and Halidule plugs go from 50 to 80%. And only a few places worked well with Syringodium. The geology determined the factor of salinity, both in Texas particularly, but also somewhat in Florida. So if you look at the shoal emergence, sandbars build up further and further, and finally they become exposed, and then the winds begin taking them down. Now, a coral reef would do the same thing. It would begin building up from the bottom. So the Florida is coral reef, the Jamaica is volcanic, and the Texas is shoal emergence. And the important point is how many breakthroughs of these shoal barrier islands, be they coral or sediment, where the ocean runs into the lagoon or to the estuary, and where the rivers run down into the estuary. Here's, not in our region, but in another region up the East Coast, East Atlantic coast, with lots of rivers, and the barrier islands having been broken through by storms. This is a map of the rivers of Texas, and you'll instantly see that Texas has huge drainage basins coming from the central part of the United States in many cases, although Florida has very short clastic rivers where the rain between the time it drops to the surface water and gets to the ocean is measured in hours. In Texas, it's measured in weeks. In Jamaica, it's also very rapidly in that steep volcanic hills runs off to the ocean. So the bays are not large bays and they are not very low salinity bays. This is the Texas coast. If you're not familiar, it goes from Louisiana down to Mexico. And these purple arrows are where we did our work. This is Galveston Bay, one of the most polluted bays in the United States, Aransas Bay, Corpus Christi Bay, Upper Laguna Madre, where we did a great deal of work for oil rigs. And here is Matagorda Bay, where we're doing 10 more pilot studies, not mentioned here, for resilience of shoreline. So the Texas data basically had 365,000 units and put in 62.7 hectares, mostly halidule and Halophila angelmannii is an understory. So here you see the halidule plug numbers, and here you see the success, which ranges from about 50 to about 100% success for the halidule plugs. The depths were very shallow. The salinity went down to 15 parts per thousand, and it stayed there for a period of time, which degrades the seagrass. The island nation of Jamaica sits just about in the middle of the Caribbean Sea, although it's on a large geotectonic plate called the Caribbean Plate, which also has Cuba and Haiti, Dominican Republic, as well as Puerto Rico and Jamaica. It served as it was discovered by Columbus in his second cruise, and it was used by both the Spanish and the British as a colony for trade. Here's a map of Jamaica with our test sites, of which we had 20. We partnered with the Department of Natural Resources, and we put in 7.8 hectares of test plots, 108,000 units at 20 sites all around the island, but they represented different pollutants, from mining and bauxite and cement to oil spills, old salt ponds, dredge and fill, and general urban waste. These are Thalassia sprigs, Thalassia seeds, halidule sprigs, halidule plugs, and Serengodium sprigs. And you see that Thalassia had quite a bit of success, particularly the sprigs, not the plugs, although a few seeds had some success, but the halidule plugs had a lot of success, as did the halidule sprigs. And this is the dredge and fill, which across all the different species had quite a bit of success. Dredge and fill in being restored. Mining, less success. And oil spill had no success at all. We were not able to reestablish on top of oil sediments any of the species. Urban waste, we were able to establish all 3 species on top of, in areas where urban wastes were actively being emitted, and erosion only for the Serengodium. The river effluent from a river which ran through peat bogs was fairly successful for both halidule and Thalassia, as well as Serengodium. But the old salt ponds where they had made salt originally, was zero success. This went up as high as 55 parts per thousand. So we learned lessons from earth sciences, how geology determines the success of the estuarine restoration, the strength of the ocean circulation, the amount of riverine water coming, and how it circulates once it's in the estuary. Of course, the rivers carry soil, silt, pollution. The extent of the plots, here we have the large-scale plantings in the three places, 75 hectares in Biscayne Bay, 2 kilometers square in Texas, and we're still doing lots of planting. And in Jamaica, we only planted 45,000 meters square, but they are still planting as they have various takings. So the discussion is that one species frequently does very well. That's why you put the test plots in. We've done this same kind of thing in Southeast Asia with the multiple species there. Depth plays an important role. It's not good success in the intertidal. About 2 to 3 feet or 1 meter is the best if you have enough light. Turbidity is a big inhibitor, as is low salinity. And you want to plant before the intense storm season, which was quite devastating to several of our plantings. Decision making is important. Expert scientists are the ones who have to decide where the seagrass goes. On top of that, the resource managers can decide what services from seagrasses they want put back. And they're the ones who should decide, on top of the places which can be successfully restored, the services that they wish. If you have a regional plan, please do not trade off success for the service benefits. And then at the end, you have to have a cost effective, which Thorhagen Austin has made a model for how you calculate your cost effectiveness. Thank you very much.